Shall I? So today we are going to start a new chapter, that is what Newton's law of motion. So write the heading, that is what NLM, Newton's law of motion. Before starting this chapter, first tell me, I think you guys have studied this three laws of motion, na? Newton's first law, Newton's second law, Newton's third law, I think in 8th standard, yes or no? Okay. So let us recall those things briefly to understand what we are going to learn in this chapter. Okay now. So tell me, what is the first law? If a body is at rest, remains at rest, and if a body is in motion, continues in motion, that to be in a straight line. That to be in a straight line. If body is traveling in a straight line, can I say that the body's velocity must and should be constant and acceleration should be zero according to the first law I am talking about. It is not necessary that if a body is moving, it should have constant velocity must. No, in the first law. In the first law. So if a body is at rest, remains at rest, and if a body is in motion, continues in motion, that to be in a straight line, that means velocity here is constant and acceleration is what? Zero. And if you want to change the state, that means if a body is at rest and you want to move that body, you have to apply some external force. Yes or no? Similarly, consider the body is in motion already and you want to stop that body. That means you want the body to be rest. Again, you have to apply some external force. Yes or no? Okay. Similarly, if you move to the second law, it states that the rate of change of momentum is directly proportional to what? The applied force. Yes or no? Okay. Similarly, if you jump to the third law, it states that the action and the reaction. For every action, there is equal and opposite reaction. Again, the Newton is talking about the force only. Are yes or no? So, to understand in all these three, he is talking about what? Force only. Are yes or no? So, what is force then? Push or pull? Okay. So, let us start with the heading. Write the first heading, that is what? Force. लिखे अभी सुनो. So force is nothing but push or the pull. Why we are calling this push or pull both? Let us try to understand this first. For example, consider here is a surface and there is a body whose mass is m. Whose mass is what? M. Initially its velocity is what? 0. Similarly, consider one more surface is available here. And on this surface, one more body is kept over here whose mass is m and this body is moving. So this body is moving with velocity v and this v is constant. V is constant. That means can I say acceleration is 0? Acceleration is what? 0. Consider this body is moving in that direction and this body is initially at rest. Okay, consider here is one person. So this is what? Man 1. And this man 1 wants to move this body. Definitely there are two options. Either the body can be moving here, either the body can be moved here. Yes or no? Consider I want to move this body in this direction. Okay, initially body is at what? Rest. And I want to move this body. Definitely this person can apply the force in this direction to move this body in that. Yes or no? Is he pushing or pulling? Pushing. So this person is what? Pushing this body. And consider one more person is available here and this person, that is what? Man 2. Okay, man 2 wants to move that body in the same direction. That means can I say that he has to pull this body in this direction? ऐसा खींचना पड़ेगा. Yes or no? So can I say that in short force is nothing but what? Push or pull. Similarly, that can be applied over here. Initially this body is in motion and I want to stop this body. I want to stop this body. To stop this body, consider one man is standing over here, then can I say that he can apply the force in this direction to stop that. उधर जा रहा है ऐसा पकड़ के खींचो उधर पीछे तरफ. That means he is what doing? Pulling this body. Similarly, one more person over here can be pushing the body in this direction. एक हो सकता है ऐसे खींच रहा हो और एक हो सकता है ऐसा ढकल रहा हो. Are yes or no? Similarly, this man can be pushing in body in that direction and over here he can be pulling this body to stop. So force in short can be written as push or pull. Okay. Accepted. So what the force is doing, छोड़ दो रे, definition कुछ भी नहीं पूछता. So force is doing what? Either the body is at rest or either the body is in motion. Force is changing the state of the body. Yes or no? So can I say that force is nothing but push or pull? Yes. It can change the state from rest to motion or motion to rest. So first thing, can I say that about the force, it can change the state of body. Solid, liquid, gas nahi hai, chemistry wala nahi. Okay, change the state of body. That means from rest to motion or motion to rest. Okay, tell me the second thing. Can I say that force can be applied and change the direction? देखो कैसे. For example, initially consider here. For example, one body is there whose mass is what? M. One person is applying the force in this direction and he is applying a force of 10 Newton. He is applying the force of what? 10 Newton. Consider this body is moving in this direction with velocity, let's say 10 meter per second. What is the velocity of the body? It is moving 10 meter per second. If I apply the force of 10 Newton, in this direction, same amount of force, then can I say that this body will come to rest? Yes, okay. So body initially motion came to rest. But if I apply the 20 Newton of force in this direction, can I say that this force becomes smaller and this force becomes greater in value? Then can I say that the body will be now moving in this direction? Yes or no? So can I say that force can also change the direction of the body? Yes. अभी देखो, इसको इधर से फोर्स लगाए, अभी अंदर लगाए तो बॉडी उधर जाएगी. Yes or no? So can I say that force can change the direction of body? Either it is moving or it is at rest. Okay. Similarly, force, can I say that change the shape of the body? देखो, मैं अभी हल्क बन गया. So initially consider this is at a rectangular shape. I can change this body to a spherical. Yes or no? So can I say that force can also change the shape of the body? Shape of the body can be changed. Yes or no? As we all know that some basic properties of the force is measured in terms of what unit? Newton. Yes. So SI unit of what? Force. Can I say SI unit is what? Newton. SI unit is what? Newton. If you are writing the scientist name, then always remember the first letter should be the small one. Okay. Either you write like this or the N value. Similarly, in terms of what? CGS system and kg system, then can I say that this value can be written as kg meter per square second. Newton's value is also equal to what? Kg meter per square second. And in terms of CGS, the same value can be written as isko kilogram, then it is represented by gram, and meter can be represented as centimeter. Time is what? Seconds only. Yes or no? And this unit, what we are writing in CGS system now, this one is called as dyne. This one is called as what? Dyne. And the conversion unit of 1 Newton is nothing but 10 to the power of 5 dyne. Okay. So these are the basic properties of what? Force. Force is nothing but push or pull. It can change the shape, it can change the direction, and it can change the state of the body. And force is measured in terms of Newton, and that is nothing but kg meter per square second. And in terms of what? CGS system, it can be represented as gram centimeter per square second. Okay. And we all know that 1 Newton is equals to what? 10 to the power of 5 dyne. So these are the basic introduction of what? Force. Now listen to me. बाद में लिखो बेटा. Now listen to me. Force is being classified into n number of varieties. Okay. So if there is a contact, then what we call, if the two bodies are not in contact, what we represent. If force is happening between two charges, then what we call that force. If force is happening inside the nucleus, then what we are going to call. If the force is only dependent on the path, that means initial point and the final point, and it won't depend on the initial point and the final point. So we are classifying the force in n number of forces. Like conservative force. Conservative force को सुनो क्या बोलते हैं. For example, ये लिखो मत. Just listen to me. These are the introduction part. No need to write. Just write about the force. Okay. Now listen to me. Consider here is the ground, and there is a body M. Initially, can I say that mg is acting in the downward direction? Or yes or no? So this is your initial position at this point. I took the body from here, and then I came and placed the body here. I place the body here. Then can I say that this is your initial position, and can I say this is your final position? Can I? If a force is only dependent on, the initial point and the final point, then we term that kind of forces. The best example here is mg. Then we call those forces are conservative forces. So conservative forces are the forces which only depends on the initial point and the final point. Similarly, we have classified the forces in one more term, that is what non-conservative force. Okay, so for example, to understand the non-conservative force, let's say there is a surface and over here is the body. Okay, consider there is a friction between the body and the surface. Okay, वो पढ़ेंगे धीरे धीरे पढ़ते जाएंगे क्या क्या होगा. Just remember how we are classifying the forces. Okay, consider here is a body whose mass is m. The contact, if there is a contact, then and then only there will be a friction. Friction को contact चाहिए ना. If I remove or holding this object in this direction, then again I am dragging on this one, then again continued over here. That means I am continuously changing or disconnecting the contact between two bodies. Are yes or no? For the friction is happening only in terms of what? Contact surfaces. So if there is no contact, no friction. हवा में किसी का friction रहेगा क्या? No. So such kind of forces, the best example over here is the friction. Friction is only dependent on what? The path. On what? Path. If we are changing the path and if I am disconnecting the contact between the two surfaces, then there is no friction. Such kind of forces we have classified in terms of non-conservative forces. Okay. Similarly, if I am applying some external force, in this case I am applying the external forces, then such kind of forces are called as what? External forces. Okay, and one more kind of force that you will be going to learn specially in WPE chapter, work power energy. Over there you will be finding a force called as pseudo force. Okay, pseudo force means we apply the force to minimize the answer. ठीक है, कैलकुलेशन इजी हो जाएगा, बहुत चीजें इजी हो जाएंगी उससे, pseudo forces. Okay. And in terms of fundamental forces, again we have classified in fundamental forces. Fundamental forces are what? Generally gravitational forces, electromagnetic forces, and the nuclear forces. Again we have classified nuclear forces into two parts: strong nuclear force and weak nuclear forces. So nuclear force is happening where? Inside the nucleus. Okay, electromagnetic force is happening between two charges. That means inside the nucleus, there you will be finding what? ऐसा रहता, देखो ये न्यूक्लियस रहेगा, over here electrons are there, at the center you will be finding protons and neutrons. So the proton is a positive charge and electron is a negative charge. So without contact is also available, na? Yes. So can I say that if we are discussing about the electromagnetic forces, you will be again finding what? Two type of forces. If two bodies are in contact, what we are going to call? If there are not in contact, what we are going to call? Generally electromagnetic force is also weak, but compared to gravitational force it is stronger. and the strongest is what? The nuclear force. ओके सो हमको न्यूक्लियर फोर्सेस के इंट्रोडक्शन से कुछ लेना देना नहीं है, बट वी रिक्वायर ओनली वन थिंग टू लर्न इन दिस चैप्टर, दैट इज व्हाट? नॉर्मल, फ्रिक्शन एंड व्हाट? टेंशन. Okay, normal, friction and what? Tension. These three are also comes under the category of what? Electromagnetic forces. Okay, and they should be having a contact. Tension में क्या होगा? You will be finding that sometimes string is what? Massless, and sometimes the string is having some mass. Okay, mass वाला string को हम generally we are classifying in terms of what? Rod. देखते हैं धीरे धीरे हम what we are going to learn in this chapter, but पिक्चर तो समझ में आ गई ना क्या पढ़ने वाले हैं. सो जस्ट राइट द इंट्रोडक्शन अबाउट द फोर्स, देन राइट द नेक्स्ट हेडिंग, दैट इज व्हाट? नॉर्मल. सो नॉर्मल, फ्रिक्शन बोथ आर द कॉन्टैक्ट वाला फोर्सेस है. नॉर्मल एंड फ्रिक्शन इज ओनली अवेलेबल व्हेन देयर इज एन कॉन्टैक्ट. ओके, टेंशन को भी क्लासिफाई करेंगे इफ मासलेस और मास डिपेंड ऑन द स्ट्रिंग. अरे गॉट माय पॉइंट? ओके, जस्ट राइट द हेडिंग and write the introduction about what? Force, then write electromagnetic force. बस इतना लिखो, electromagnetic force. In that electromagnetic force just write tension, normal and what? Friction. Okay, now write the heading, that is what? Normal. You want to write normal as force, you can write this as force. In some books you will be finding this as terms of reaction. You can write the reaction also, whatever the wish is, but in reality normal is a force. Let us try to understand what kind of force is this, what will be the direction of this force. Do this force, that is what normal, will be having the component y, because force is a vector quantity na. Are yes or no? If force is a vector quantity, that means it will be having the components. Do normal also have the component? Do normal have the direction? Yes or no? So let us try to understand all those things. But before that, for example, consider there are two bodies like this. This one is having mass 1. Consider this as the Earth surface. Earth is having a huge mass. Yes or no? These two bodies are in contact? No. If there is no contact, even though, can I say that mg is acting in the downward direction? Yes or no? Mg is acting in the downward direction. Either the bodies are in contact, either like this. Both bodies are in contact, having the same mass, even though mg is acting in the downward direction. So mg is acting in the downward direction towards the center. Yes or no? उसको डिटेल में पढ़ेंगे ग्रेविटेशन में, but we know that it towards the center of the earth. Now mg is acting in the downward direction. Over here mg is also acting in the downward direction. Over here the surfaces, two bodies are in contact. Over here the bodies are in not contact, even though mg is acting in the downward direction. But what about the normal? Over here normal value becomes 0. Normal do not exist if there is no contact. So what is the first most thing to have the normal? Normal should have, the bodies should have what? Contact. Two or more bodies should have what? Contact. Then and then only normal will be existing. Normal will be existing. Second thing, let us try to understand this. What will be the direction? Okay, what will be the direction? इधर सुनो ध्यान से. Consider this is your Earth surface. Again, now consider I am having a balloon, and this balloon is considered spherical in shape. Okay, and I filled this balloon completely with what? Water. Okay, when I place this balloon on ground, the same balloon look like this. ये नीचे से फ्लैट जैसा हो जाएगा. अरे yes or no? Yes. Okay, let us try to understand this. What is happening in reality? Both are applying the forces. That means what I am saying, Earth surface is also applying the force on this body, and this body is also applying the force on this Earth. Let us try to understand. Consider here is my finger and here is my arm. Okay. If I apply some force on this hand, then can I say that this body is getting deformed? Shape change हो रहा है मेरे हाथ का. अरे ये deform हो रहा है ना. अरे yes or no? So my hand is getting what? Deformed at this point. At the point of where I am applying the force, and this point is called as point of application. If I am applying any force on a particular point, then that point is called as what? point of application, and where I am touching this point, and that particular point is called as point of contact. ठीक है, अभी यहाँ आ जाओ. So when I am applying the force on my hand in this direction, my body is getting what? Deformed. That means my hand is getting what? Deformed. Yes or no? So where I am applying the force? In the upward direction. Consider I am applying the force in the upward direction. This body is getting deformed in the upward direction. Similarly, can I say that this hand is also applying the force on this finger also? Yes or no? तुम ध्यान से देखो, if you are touching your hand, both fingers get deformed. Both finger get what? Deformed. Similarly, can I say that when this mass and the earth surface are in contact, earth also get deformed and this body is also getting deformed. We can't see with visible eyes, but deformation hoga. Okay, now let us try to understand. This is your earth surface and this is your balloon surface. Okay, now when they both are in contact, at this point, at the contact position, both get deformed. Now how this is happening? Balloon tries to press earth in the downward direction. Balloon is applying the force on earth in the downward direction, and earth is applying the same amount of force on the balloon in the upward direction. So can I say that this is nothing but force on earth because of what? Balloon. Okay, force on earth with respect to balloon, and over here this is the direction of what? Force on balloon with respect to earth. Okay, अभी इसका खासियत सुनो. Are they changing the shape? Are they changing the shape? Okay, now balloon is trying to deform the earth in the downward direction, upward direction. Force नीचे लगा है तो earth का deformation नीचे होगा ऊपर होगा? नीचे होगा. That means can I say that the normal which is been force is nothing but normal. So can I also write this as normal of earth with respect to balloon, and this force can be written as normal of balloon with respect to earth? Can I? Balloon, body, कुछ भी बोलो. Okay, now listen to me. Who is applying in the downward direction normal? Balloon. So can I say that normal will always have the direction? Normal will always have the direction as the shape of the body is getting deformed. Deformation का direction ही normal का direction होगा. I got my point. So who is getting deformed? Because of balloon, earth is getting deformed. Earth is getting deformed in upward direction or downward direction? Downward direction. आगे बात. So what will be the direction of what? What will be the direction of normal? Normal always shows the direction along the direction of deformation. याद रहेगी बातें? Okay, now let us come back here. Okay, who is applying this mg? First tell me. Who is applying this mg? Initially we saw that if they are not in contact, mg is acting in the downward direction. If they are in contact, mg is acting in the downward direction. So can I say that this mg is nothing but normal इसको मान लो block, and this is your earth. Okay, so in this direction, downward direction, who is trying to press the earth? Block is trying to. Yes or no? So can I say that this normal is nothing but force on earth because of balloon? Block. Yes or no? And what will be the direction of now? The earth will apply the force in the upward direction. So can I say that earth will apply the force on this block in the upward direction? Then can I say that this is nothing but NBE? Yes or no? But we don't represent all these things in a FBD. Okay, we just only represent like this. Consider here is the block. If this is having a mass, over here is mg, and over here will be acting what? Normal. Okay, who is applying this normal? Who is applying this normal? Earth is applying the same amount of force. Earth is applying the same amount of force on the block. The what block is applying on the earth? आगे बातें. Okay, the third thing you will be finding what? First what? Sorry. This will be having the direction is always along deformation. Okay. Third thing, forces are equal and opposite in direction. Third thing what we have learned, these forces are what? Equal and opposite in direction. I got my point. So if you, let us try to understand this with one more example like this. Consider here is the surface and this is the block having a mass m. Okay. Now, if I zoom this surface, the contact surface over here, between the two surfaces, if I zoom this to the microscopic level, then can I say that the surfaces will look like this? Or yes or no? This one consider for the block and this one is your earth surface. Like this. Where are the contact points? So can I say this is the contact point, this is the contact point, over here is the contact, over here is also contact, over here is also contact. Okay, contact is always perpendicular to what? Normal, sorry, not contact. Normal is always perpendicular to the contact surface. At this point, let's say the normal is acting in this direction. At this point, let's say normal is acting in this direction. At this point, normal is acting in this direction. Consider at this point, normal is acting somewhere like this. And at this point, normal is acting like this. So at every different points, you will be finding the normal's directions are different. Okay, but if you take the resultant of all these normal, you will be finding that normal is always acting in the upward direction, that is perpendicular to the contact surface. Are yes or no? So all these normals will be having different direction, but the resultant is always perpendicular to the contact surface. So what will be the normal direction? Can I say that perpendicular to contact surface? Perpendicular to what? Contact surface. So what we have learned, normal is only exists if two surfaces are in contact. Normal will always have the direction along the direction of what? Deformation. The forces are equal and opposite in direction. Okay. And the final normal is always perpendicular to the contact surface, and it is the resultant of all contact of the chinna points. Are yes or no? Okay. Shall I? The next point, whatever the point number is. Consider two bodies are placed like this. Body 1, body 2, body 2 ऐसा बना देंगे इसको. So this is your consider point block A, this is your block B. How many contact surfaces are there? 3. First thing, contact number 1 with body 1, body A. This is the contact of body B. Can I say A and B are also in contact here? Are yes or no? So let us represent over here. Mg of A is acting in the downward direction. Mg of B is acting in the downward direction. Normal which is being exerted by the earth in the upward direction. And this one is also having the direction in the upward direction. Yes or no? One more contact surface is there here. Let us discuss about this point. Okay, this is the contact surface now. Are yes or no? Now consider, and first tell me, this is your block A, this is your block B. Where A is applying the normal on B. Normal on B means nothing but what I am asking, where A is applying the force on B. Simple. That means, can I say that A is applying the force in this direction? Are yes or no? Then can I say that this is the normal on B due to A? Yes or no? Okay. Similarly, what will be the direction of normal which is being produced by B? Then it is in opposite direction, let's say here. So then this is the direction of what? Normal on A because of what? B. Yes or no? Yes? Okay. Consider initially this system is at rest. This system is at what? Rest. If I apply the force in this direction, some external force I applied here. Okay, and this body started to move in this direction with velocity v. Maybe this velocity is increasing or decreasing, or maybe this one is having acceleration 0, or maybe this one is not acceleration 0. Either the acceleration is 0, either the acceleration is not 0, either the velocity is constant, either the velocity is not constant. Increasing, decreasing, whatever it may be. But I applied the force in this direction. Even though the force which is exerted on B because of A, that means normal of what? Normal on A because of B will always follow this same direction. These directions are unchanged. Okay? Even though if I apply the same amount of force in this direction, if F external is being applied in this direction, even though the direction of NAB and the direction of NBA are unchanged. Okay? बात समझ में आई? So either the body is at rest, or either the body is in motion, either the body is accelerating, either the body is moving with constant velocity. The normal between these two, that means the normal which is being produced by A on B will follow this direction only, and the normal which is being produced by B on A will follow this direction only. Normal direction does not changes. So direction of what? Normal remains unchanged. एक point ऐसे लिख लो. Remains unchanged. Even the body is at rest or in motion. Motion में भी दो चीजें होनी चाहिए. Either the acceleration is 0, either the acceleration is not equal to 0. I got my point. Write down this. Okay, shall I? अभी थोड़ा star mark बना लो. Why? Because sometimes we get confused during the direction of what normal. Let us say here is a system like this. Consider this is a system, and I placed one ladder like this. Okay, one ladder is being placed. Okay, consider, tell me the direction of normal. That means, can I say that this is your first point of contact? So this is your point of contact, and can I say that this is also your point of contact? थोड़ा ध्यान से सुनो अभी. Okay, two bodies are in contact, then and then only normal exists. Normal always exists perpendicular to the direction of what? The force or the contact surface. Abhi, contact surface. Very good. Now tell me, body is completed here. There is no extra body beyond this. Ladder है क्या नीचे? नहीं है. Ladder खत्म हो गया ना इधर? Yes or no? Surface खत्म हुआ क्या? Surface is available before the ladder. Surface is available after the point of contact. Yes or no? Consider this is your body and this is your surface. ऐसे याद रख लो. Body and surface. So surface is available on either sides or on both sides of the point of contact between body and the surface. Yes or no? Okay. Then always remember to substitute the normal perpendicular to the surface. किसके perpendicular होना चाहिए? Surface के. If surface is available on either side. Okay. Now, similarly, can I say that at this point of contact also, surface is available here also and surface is available here also. Then I have to draw a perpendicular line with respect to what? The surface, not with respect to the body. अगर with respect to body बोलेंगे तो इधर जाएगा and that will be wrong direction. Okay, then you have to represent in terms of component also. वो भी देखते हैं, ठीक है? Similarly, the same thing can be presented like this. Consider here is a spherical surface and like this. Okay, these are the contact surfaces. मुझे बताओ नॉर्मल किधर होगा? Body, consider here is the contact surface. This is your point of contact and this is also your point of contact. So both body and contact surface both are available on either side. देखो body भी point of contact के इधर available है at the bottom also. Similarly at this point of contact body is available on the upper side also and in the downward side also. So body is available, yes. Similarly on, let us talk about the surface. At the point of contact surface is available over here also, surface is available on the either side. Similarly on this side also surface is available on both sides. Then always draw a perpendicular on both. Okay, then can I say that this point of contact for this surface and for this sphere is nothing but acting as tangent. Acting as what? Tangent. Definitely then the normal will be passing through what? Surface. This is the normal 1 and this can be represented as what? Normal 2. Again this is 90 degree. Okay. Now let us try to understand with one more example. थोड़ा और deep जाएंगे. Consider this is the surface. Okay. Now I place the ladder like this. So here is the surface and this is the ladder. Point of contact बताओ. So this is the first point of contact. Are yes or no? Surface is available here also. Surface is available here also. Then where will be the normal? Perpendicular to the surface. That means this is the normal at this point. Can I say the body and the surface both are having a contact here also? यहाँ पर भी एक contact है. Are yes or no? Now who is available beyond the point of contact on either side? Body is available or surface is available? Yes, very good. Hallu bolo, hallu bolo. So body is available on the either side. Surface is not available on either side this time. So you have to draw the normal perpendicular to the body. That means, can I say this will be the direction of what? Normal. Okay, if body is available on the beyond on either side of the point of contact, draw perpendicular to body. If surface is available on either side of the point of contact, draw perpendicular to what? What? Surface. If surface and body both are available, किधर भी बनाओ perpendicular ही आएगा. दोनों के लिए perpendicular common होगा. Are yes or no? Okay. Let us say one more example. ऐसे कर लो. Consider like this. Again sphere is available, but this time the surface is passing through the diameter like this. Diameter ये diameter के पास है, center की तरफ से जा रहा है. Okay, this is the center. Here is the also point of contact. Here is also point of contact. Surface is available beyond point of contact or body is available? Body is available. So body is available here also in the upward side. Body is also available in the downward side. Even if you draw a tangent, this tangent will be exactly parallel to this bottom line. Yes or no? Then obviously can I say normal will be in these directions. So this is the directions of what? Normal. Okay. अभी इसी को थोड़ा सा modify करेंगे. Consider like this. Now this time it is not passing through the diameter. ले अब बताओ who is available? Yes, again body is available. Again you have to draw what? Tangent on point of contact. Then can I say that this will be acting as the tangent? Similarly here also this will be acting as the tangent. Are yes or no? Then normal will be perpendicular to the contact surface, that is point of contact. Then this will be passing over here and this one will be passing over here. आ गया समझ में? Okay. And let us try to understand with components also. Door देखे door. उधर का door देखो. That door is been hinged. So consider this my hand like this. This is the door. Okay. So door can be opened like this and closed like this. Yes or no? Door ऐसा तो बंद नहीं होता ना? Or yes or no? That door. If hinges are applied over here, then this can be opened and closed like this. But I am saying that this door is been hinged like this. If you apply the force in the downward direction, in the downward direction and this hinge will be fixed ना. डोर को क्या करो, ऐसे पकड़ के ऐसे नीचे प्रेस करो, डोर खुलेगा बंद होगा नहीं होगा. Then where will be where you are applying the force? In the downward direction. Normal will be acting in the upward direction. Yes or no? Same door, उसको पकड़ के ऐसे बाहर खींचो, बाहर आएगा डोर नहीं आएगा. Then if you are applying the force in the front side, that means towards you, that means you are pulling the door. Okay, then those hinges will apply the force inside the door. ठीक है. अरे आया क्या भाई समझ में? एक बुक पेन पेपर कुछ तो दे दो. ओके, थैंक यू. सो कंसिडर दिस इज योर डोर. This is your door like this. Okay, if you are pressing the door in the downward direction, if you are applying the force in the downward direction, then the hinges will apply the force in the upward direction. Okay, and if you want to pull this door, then my hand will try to apply the force in the backward direction ना. मेरे हाथ को फिक्स रखो, देखो हाथ खींचने की कोशिश करेगा. Yes or no? Similarly, if a body is been hinged, जब भी hinged वाला क्वेश्चन आए, okay, for example, consider here is one a rod, door, whatever it may be, and consider this is fixed here. This one is fixed here. Nut से लगाओ, bolt से लगाओ, किससे भी लगाओ, consider it is fixed here. Can I say that this body can be rotating on this direction? Yes or no? If I apply the force in this direction, definitely this force will be converting this body to rotate on a particular axis. Then that particular force is again called as torque. ठीक है, याद रखो. If I am applying a force, you will be hearing this torque also in circular motion, rotational motion. वो chapters आने दो. Okay. Now, if you are applying a force in this direction, this body started to rotate like this. Yes or no? On a fixed point, that is what? Hinged point. This one is called as what? Hinge. ठीक है. So the body will start to rotate on a particular fixed axis. Then that particular force now is called as what? Torque. अभी वो देखते हैं बाद में. If I want to pull this in the downward direction, then this screw will apply the force in the upward direction ना. So force is applied in the downward direction. This screw will apply the force in the upward direction. Okay, and if I want to plug this, बाहर खींचना चाह रहा हूँ उसको, उखाड़ना चाह रहा हूँ, then this screw will apply the force into the board. Okay, then can I say that the same body on a same point, on this hinged point, you will be finding two normal. One is inside the board and one is in this direction, depending on the question where we are applying the external force, what is happening to the normal. So normal can be represented like, let's say over here is your normal in the x-axis and over here in the y-axis. Why? Because normal is a force and force is a vector quantity. Definitely it will be having their components. आ गया? Okay, shall I? Now write the example number 1. छोटे छोटे examples करते हैं. Tell me the answers in oral. Okay. Now consider, here is a surface. On this surface, one object is being placed like this. Let's say this object is having a mass of 10 kg. Mass of what? 10 kg, and take g is equals to 10 again. Here in this chapter also we are going to take g as 10. Okay, now tell me, where is direction of mg? Downward direction. Where is the normal? Upward. Very good. So normal is acting in the upward direction. We already discussed that mg and normal both are equal. Then can I say that n is nothing but mg and n is nothing but what? 10 into 10, that is what? 100 Newton. Okay, now अभी free body diagrams जो बार बार हम word use कर रहे हैं, what is the meaning? At this point, on this body, how many forces are acting? Two forces. One force is in the downward direction, that is what? mg, and one force earth is applying on the body, that is what? Normal. खत्म है इसका FPD. ठीक है, अभी देखते जाते हैं, बहुत सारे बॉडीज आएंगे. इसका बताओ आंसर मुझे. Consider this one is 20 kg and one more body is placed on this body. This one is what? 10 kg. How many contact surfaces are there? Two contact surfaces. So can I say this is your contact surface number 1 and can I say this is your contact surface number 2? This is again your earth. ठीक है? Okay. Now what is happening on this body? Body number 1. This is your body 2. Okay? अर्थ का नहीं निकालना है हमको. ठीक है? Now, so on body 1 is trying to press in the downward direction. Yes or no? So mg कितना लगेगा body 1 पे? In the downward direction. Yes or no? So can I say that this body 2 will apply force in the upward direction? Are yes or no? So this is the direction of what? The normal which is being applied by whom? Body 2 on body 1. लिख सकता हूं कैसे? उसका सेपरेट सा डायग्राम बनाएंगे इधर. So this is the direction of what? Normal on body 1 because of body 2 and this is the direction of what? Mg. Are yes or no? Can I say both will be equal? So can I write like this? NB1 B2 is nothing but mg and m mass of the first body is what? 10 kg. G is also this. So this NB1 B2 which is equals to 100 newtons. अरे yes or no? तेरे को लात मार के बाहर ढकल डालूंगा नेक्स्ट टाइम. ठीक है? नाउ लेट अस डिस्कस ऑन दी बॉडी 2. व्हाट इज हैपनिंग ऑन बॉडी 2? इस बॉडी पे देखो अभी बॉडी 2 पे. बॉडी 2 mg विल बी एक्टिंग इन द डाउनवर्ड डायरेक्शन. यस, दिस बॉडी इज ट्राइंग टू प्रेस दिस बॉडी इन द डाउनवर्ड डायरेक्शन. फर्स्ट बॉडी. Yes or no? Can I say that this body is applying the force that is in the downward direction, that is what? N of what? B2 because of B1. Yes or no? B2 also apply in the upward direction. Then again can I say this remains as it is in the upward direction. So can I write this as mg plus of NB2 B1 which is equals to B1 B2. Are yes or no? Yes. Okay. Then substituting the value, can I get the answer? कितना होगा? कैलकुलेट करो, बताओ जल्दी. क्यों रे दिमाग खराब हो गया? ओके, सुनो गलत कर रहे बेटा, तुम ऐसे नहीं कर रहे. सुनो, नाउ लिसन टू मी. mg का वैल्यू कितना है? What on what body we are discussing? This is the representation of body 2. This is the representation of what? Body 1. Body 2 का मास कितना है? 20 kg. So 20 into 10, that is what? 200. Are yes or no? Okay. Body 2, on body 2 because of body 1 in the downward direction. Who is acting in the downward direction? Because of that. What is the normal of this body value we got? 100 Newton ना? Are yes or no? So plus of what? 100. इसको ऐसे लिख लो, नहीं तो इसको N1 लिख लो. इसको क्या है? N2 बना दो अभी. ओके, ये एक्सप्लेन करने के लिए बताया, धीरे धीरे तुमको आ जाएगा. ओके, सो 200 प्लस ऑफ दिस 100 दैट इज नथिंग बट 300 न्यूटन. सो N2 वैल्यू विल बी 300 न्यूटन. एक और करते हैं, ठहरो. 4 बॉडी सिस्टम बनाएंगे. ले ये 10 20 30 40. ठीक है, कहां से स्टार्ट करना है? N1 N2 N3. सो N1 का डायरेक्शन बताओ, इधर ही फिगर में बता दो. N1 इस सरफेस का N1 ऊपर. यस, फॉर दिस सरफेस N2, फॉर दिस सरफेस N3, फॉर दिस सरफेस दैट इज व्हाट? N4. यस, पकड़ो N1 को. mg in the downward direction, N1 in the upward direction. For this N1 is equals to what? mg. Values बता दो. 10 kg, that is N1 is equals to what? 100 Newton. Yes? Okay. N1 का वैल्यू सेम mg नीचे भी तो लग रहा है. किस पे लग रहा है? सेकेंड बॉडी 20 kg का mg लिखो सबसे पहला. Yes? Because of this body, that means top body, this one is being pressed in the downward direction. तो ये किसका डायरेक्शन है? N1 का. N2 का डायरेक्शन किधर है बेटा? ऊपर. Yes, very good. So N2. So can I write N2 is equals to N1 plus of mg. जो भी वैल्यू आ रहा है आंसर आपका. ओके, Similarly, let us move to the third body. Third body का weight 30 kg. So this one is mass 30 kg. So mg. Yes. इसका n3 ऊपर, इसका n2 नीचे. तो ये वैल्यू क्या हो जाएगा? n2 प्लस ऑफ mg. That is your n3. Are yes or no? Now come to the fourth body. Come to the fourth body. Fourth body पे क्या हो रहा है? Mass 40 kg, mg downward direction, इसका नॉर्मल ऊपर, that is what n4. इसके ऊपर n3 भी तो नीचे लग रहा है. आगे बात. अभी how to do without all these things. इसका मास कितना है बेटा? n1. तो इसका नॉर्मल कितना होगा? 100. इसका मास कितना है? 20. अरे यस और नो? 20 का प्लस ऊपर कितना हो जाएगा? 30. इसके ऊपर 60. इस पे कितना होगा? 100. अरे आया क्या भाई? सिंपल. देख लो, सॉल्व करके देख लो, उतना ही मिलेगा. यहां लगा लो. वैल्यू कितना है? n1 का 100. 100 प्लस ऑफ दैट 20, 300 न्यूटन. इसका n3, n2 कितना मिला हमको? 300. mg कितना है? 300. आंसर कितना होगा? n3 600 न्यूटन. इस पे देखो 1000 न्यूटन. अरे यस और नो? n3 600, दिस वन इज mg 400, 1000. करेक्ट है? जो बता रहा हूं वो करेक्ट है कि नहीं देख लो. 10 kg का नॉर्मल 100. 10 kg प्लस 20 kg कितना हो गया? 30 kg. 30 kg का mg 300. अरे यस और नो? देन 10 kg प्लस 20 kg प्लस 30 kg, बस मास को ऐड करना है तुमको. सो दैट इज व्हाट? 60 kg. 60 kg इंटू जी, दैट इज 10, 600. ऊपर से लेके पूरों को ऐड कर लेते जाओ. 100 kg होगा. 100 kg जी वैल्यू 10 अगेन 1000. सिंपल. इसमें कंफ्यूज मत होना. ओके, राइट ऑन. ओके, शैल आई consider? Here is the surface like this, and this one is what? 53, 90. One object is being placed like this. इसका मास है 10 kg. ओके, कितना होगा नॉर्मल? 100 क्या कंपोनेंट वाला? वेरी गुड, कंपोनेंट. सो mg will be acting in the downward direction. अरे yes or no? Can I say this one component over here? This becomes ng cos of 53 degrees, क्योंकि ये 53 होगा, हमको पता है ऑलरेडी. Yes or no? इसका तो कुछ चाहिए ही नहीं हमको. mg sin 37. Where is the normal? Normal is always perpendicular to this contact surface. That means normal direction will be here. Then can I write normal is nothing but mg cos of 53. m is how much? 10. That is what? 100. 100 into cos 53 कितना होता भाई साहब? 3/5. ओके, दैट इज व्हाट? 60 न्यूटन. खत्म आंसर. ओके, अभी ये करो. $37, ये 20 kg. इसके ऊपर रखा है और एक लो 10 kg. n1 का डायरेक्शन ऊपर, n2 का डायरेक्शन भी ऊपर. अरे यस और नो? आंसर बताओ जल्दी. 37 दिया ना बेटा, यहाँ पे 53 लेता करते. ओके, सुनो. दिस वन विल बी इक्वल टू व्हाट? mg cos of 37. That is nothing but equal to n1. So n1 is nothing but mg of cos of 37. Cos 37 is what? 4/5. And mass is how much? 10 kg. So 100 into 4/5. That is nothing but what? 80 Newton. That is what? n1. Yes or no? Okay. Similarly for mg of this one is also acting on this mg. इसका cost of 37 होगा. ये भी तो है ना. इसका n2 ऊपर, इसके ऊपर mg और एक n1 कहाँ लग रहा है? इधर ही. So can I write n2 is nothing but n1 plus of mg cos of 37. इसका मास कितना है? सेकेंड ब्लॉक 20 kg. n1 80. So 80 plus of 20, 200 into 4/5. that is what this becomes 80 60 barabar. Okay, and then 60 180, that is what 240, correct hai na? Okay, so N2 is equals to what? 80 plus of 160, that is what 240 न्यूटन्स. कुछ भी नहीं है बेटा, बड़ा सिंपल सा आंसर है. ओके, लिख लो. ओके, चलाए. ये एक ऐसा सरफेस है, स्पीयर, एंड दिस स्पीयर इज बीन स्टक लाइक दिस. This one is 60. This one is having 20 kg mass. Find normal. Find what? Normal. Try करते? हाँ करो. Okay, shall I? And those who have used component, excellent. उनका आंसर करेक्ट है. First thing, I already told you this normal will be passing through the center. Consider this is your N1. And at this point, this one is also passing through the center. This is what? N2. Okay, body एक ही है तो ये N1 N2 लिखने का कोई जरूरत नहीं है. Why? Because this one is making an angle 60 degree also. Okay, now listen to me. If this one is making 60 degree, then this one is the center. Then can I say that this one will be passing exactly through the center? Yes. Okay. Then इसको फिगर को बाहर निकालो. At this point, this is your N. At this point, this is your N. Over here, can I join these like this? है ना? अब ये कितना हो जाएगा? 30. This also becomes what? 30. Okay. If I join these centers like this, that means if I take this as over here, ये कितना है? 90. ये एंगल 90 होगा ना बेटा. रेडियस एंड टैंजेंट इज ऑल्सो ऑलवेज इक्वल टू 90 डिग्री. बचपन में पढ़े सर्कल्स चैप्टर में. ओके, नाउ इफ दिस इज 30, दिस इज 90, ऑब्वियसली दिस बिकम्स 60. इफ दिस इज 60, देन इफ दिस इज 60, then this angle is what? Perpendicular to each other, then this becomes 30. Are yes or no? If this is 30, then what will be this value? कर लो, आ जाएगा. ओके, और नहीं करना है तुमको, और कुछ भी नहीं करना है. इफ दिस एंगल इज 30 डिग्री, दैट मीन्स दिस एंगल, ये एंगल 30 है तो ये एंगल भी आपका 30 होगा. ये एंगल 30 है तो ये भी एंगल 30 होगा. और शॉर्ट हो गया. इफ दिस इज 30, दिस इज योर n, देन दिस बिकम्स n cos of 30 degree, and over here this becomes n sin of 30 degree. Similarly, this also becomes what? n cos of 30 degree, and one more component will be going here, n sin 30 degree. That means can I say these are equal and get cancelled out? बच गया क्या तुम्हारे पास? सिर्फ 2n sin of 30 degree, which is equals to what? mg. नीचे तो mg ही काम करेगा ना इस पे. mg will be acting in the downward direction like this. अरे yes or no? So 2n sin 30 degree is equals to what? mg, and sin 30 is 1 by 2, then this and this get cancelled. n is nothing but mg, and n का वैल्यू कितना आया? 200 न्यूटन. किसका किसका है ये? एक्सेलेंट, एक्सेलेंट, वेरी गुड. फर्स्ट क्वेश्चन में अच्छा आया आंसर. ओके, राइट ऑन. ओके, वन लास्ट क्वेश्चन ऑन नॉर्मल. बस इसके बाद स्टॉप करते हैं. नॉर्मल पुली सिस्टम को जाते हैं. ठीक है. नाउ एग्जाम्पल नंबर वॉट एवर इट मे बी. Given that like this, one more sphere is there, and this sphere is being placed like this. ये सेंटर से यहाँ नहीं पास हो रहा भाई साहब, ये वाली सेंटर है. Okay, remember like this. So this is over here and passing like this. ये कुत्तों को भोगना जरूरी होता है क्या? सुनो, चलो. And given that radius of this sphere is 10 meters, this one is equal to this width is what? Length is what? 10 आया ना, 5 2, इसको 16 meters ले लो. and this mass is 20 kg. Find normal again. Same question, find normal. अच्छा ये बताओ, will it passes through the center normal or not? Check yourself. Okay, let me surface is available or sorry, body is available or surface is available? Body is available. That means I have to draw a tangent on the body like this, and over here can I represent this like over here? Yes or no? Definitely it will be passing again through the center. That is what, this is your n1, this is your n2. mg will be acting exactly from here. If this is phi, obviously can I say this is also phi? यहाँ से यहाँ तक this also becomes phi, and this also becomes what? Phi. Are yes or no? Okay, and center से pass हो रहा है. अरे नहीं, sorry, it becomes 8, sorry dear, sorry. So this becomes 8, and this also becomes what? 8. Okay, now again if I continue this, angles ढूंढो, then this इसको side में कर देंगे. So over here is one normal, over here is one normal. mg is acting in the downward direction, and if I join these like this over here, then you will be finding one more thing like this over here, and ये कितना हो रहा है भाई? 8 हो रहा है. ये भी कितना हो रहा है? 8. Okay, radius is 10. That means this becomes 5. This also becomes what? 5. Sorry, radius is 10 now. This is 10, and this is also becomes what? 10. ये वाला radius is given ना 10. So this also becomes 10. This also becomes 10. ये वाला 10. ये वाला कितना मिला हमको? 8. Yes or no? And you will be finding a right angle triangle over here, and this becomes a right angle triangle. Can you calculate this value? हो जाएगा ना? थीटा निकाल लो. Cos theta 8/4. That means 4/5. Solve this, then tell me the answer now. Okay, हो गया सभी का आंसर. Now listen to me. So this also and this angle becomes equal. Yes or no? If this angle and this angle also becomes equal. If this is equal, obviously this also becomes equal. These two components get cancelled. Cos theta wala. Okay. Now tell me the angle. If this is what theta, then cos theta is nothing but 8/10. This becomes what? 4. This becomes of 5. Then theta is nothing but cos inverse of 4/5. Then can I say theta is nothing but 37 degree? Yes. Okay, then solving for this, then theta is 37 degree. This also becomes 37 degree, and this becomes n. ये वाला ऊपर जाएगा n sin of 37, और इसका वाला भी इधर ही आएगा n sin of 37 degree. Then can I say that this n normal and this normal, that means cos component get cancelled. So 2n sin of 37 degree, which is equals to what? mg, and sin 37 is what? 3/5. Okay, so n is nothing but n is equals to 3 to 6. 6/5 is equals to m is how much? 20 kg. That is what? 200. So normal is equals to 200 into 5/6. किसका आया? Very good. Solve this, and this is your final answer. Okay.